And modeling with geometry 5.7. So these first ones kind of just some practice talking about circumference and area. Remember, circumference of a circle is 2 times pi times the radius. Area is pi times the radius squared. So, if the radius is 3 feet, well then we just plug it in, right, for each one. And apparently they want us to leave your answers with pi. So basically you don't worry about pi. So 2 times the radius would be 6 pi. 3 squared would be 9, so the area would be 9 pi feet squared. That would be feet. Okay, so it kind of eliminates needing a calculator. Now the diameter, basically the circumference, we could also say the diameter times 2. Or no, I guess the diameter times pi would be the circumference. Because if you cut the diameter in half, the radius would be 7, but then 7 times 2 is 14, so you'd end up with 14 pi anyway. So the area would be 7 squared, which is 49 pi. Okay, 38 pi kilometers, okay, for the circumference. So the radius, that would be 2 pi r equals 38 pi. The pi's would cancel. So I just divide by 2 to get 17 for our radius. If I know what our radius is, I just go 17 squared to get 289 pi kilometers squared. I guess centimeters squared. Centimeters. Kilometers. Okay. So next one. 49. The area is 49 pi. Okay, so I'd go pi r squared equals 49 pi. So those cancel, then we just take the square root of it. So the radius would be 7, so the diameter would be 14. Hopefully you noticed that right there. So the circumference would be the same circumference, right? 14 pi. Almost doubled it there. Okay. Now the circumference is 15 pi. So the radius would be half of 15, right? Which would be 7.5. So the area would be 7.5 squared, or 56.25 pi. The last one, area of 121 pi. So pi r squared equals 121 pi. Cancel out the pi's, take the square root. 121 would be 11 for the radius. Circumference would be 22 pi. Alright, now it says solve for the missing angle. Round your answers to the nearest degree. Okay? So, number 7. Cosine of theta is 1/6. Well, using your calculator, you just go the inverse cosine of 1/6. So I type that in. And we get 80 degrees, because it said round to the nearest degree. So tangent, same idea. Do the inverse tangent in my calculator of 2/3. And that'll tell me my angle. Would be 33.69, so 34 degrees. Same with the sine. Inverse sine of 7/8. So all you really need is that calculator to help you do these parts. And theta would be, the angle would be 61 degrees rounded. Now on number 10, first we'd add 2 to both sides to get 5 sine of theta equals 2. Divide by 5. So sine of theta equals 2/5. Then we just do the inverse sine of 2/5, and we get theta. So the inverse sine of 2 divided by 5 would give us 23.57, so 24 degrees. Same with this one, add 6. 7 cosine of theta equals 6, divide by 7. Cosine of theta equals 6/7. And obviously we're doing the same thing here. So theta equals inverse cosine of 6 divided by 7. 31 degrees when we round. So you should be able to figure out that we're going to, basically have tangent of theta of 1/4. So the inverse tangent of 1/4 will give us theta, and theta would be 14 degrees when we round. Okay, that's all we do on those ones. A lot of calculator work. Alright, now here's our rules for the sine, the cosine, and the tangent of the law of sines and the law of cosines. So with the law of sines, we can write it with the sides on top or the angles on top. It really depends on if you're looking for angles or sides. Whichever you're looking for is typically what you want on top. Okay, and when they have that little a over a, it means whatever angle you have, it's the one opposite. That's what the connection is. So often they'll write their triangle like this. So big B and little b, C and C across from each other. And it works the same way for law of cosines. This one's a little more complex, but if you're given any of these pieces, you can find the other ones. And basically, with law of sines, you're only going to pick two of them. Okay, so if I have an angle and two sides, I can find that opposite angle. Or if I have two angles and a side, I can find the other one. Okay, and all three of them work together. So I could do sine of A over A equals sine of C over C. Okay, so basically I need that connection. Whereas with law of cosines, you have all sides and an angle. Okay, now using the math, we can figure out for any one of them. Okay, so that's kind of what we're going with. So let's take a look at this one. So, law of sines, so I've put it down here, the bottom of the screen. So I've got an angle C, I've got a little side C. I've got an angle A, or B. I want to find little b first. So, I'm looking for a side, so I'd probably go, I know what sine C and C are, so I'm going to set that equal to B and sine B, because I know what sine B is. Can I figure out sine of A, or just A? Yeah, because I know that 180 minus 135 minus 10 is going to give me what angle A is. So honestly, I could do that one first. Do the 180 minus 145, basically. Right, because 10 plus 135 to get 35. So I know that's 35 degrees. So, but to use the law of sines, I set it up this way. So 15c over the sine of 135 is equal to b over the sine of 10. So to get b by itself, I multiply by the sine of 10 on both sides. So basically I end up with sine of 10 times 15 over sine of 135. And that's going to equal b. That's what I plug into my calculator. So once again, we're using calculators a lot to help us out with this stuff. So sine of 10 times 15 divided by sine of 135. That should give me about 3.68, we'll say. Okay. Alright, now to find little angle A, we set it up again, and I would use the C as well again. Kind of the same idea, but instead of that B, we're going to use the sine of 35 degrees because we figured that one out, an A. So I times everything by sine of 35 degrees instead. So this ends up being the sine of 35 degrees. So it's basically that same idea. And we end up with 12.17. So there we go, solve the triangle. Okay, scoot this over, clear some space. So now 14, same idea, we've got angle C, we've got angle C. We've got B, little a, big A. Can find big A, it's actually 35 degrees again, because 105 plus 40 is 145. Subtract from 180 is 35. Okay, so the first step, if you have two angles, find that third angle. Then we're going to do the same thing again, right? So I want to find angle B, and I know that or side B, I know the angle B is 40, and I know the C's, so I can set it up. 10 over sine of 105. Okay, what am I going to do? I'm going to times both sides by the sine of 40. That cancels that out. I'm left with B equals 10 over the sine of 105 times the sine of 40. That's what I put into my calculator. And then that gives me my answer for B. Okay, for A, same idea. I want to find A. I know that angle A is 35 degrees. It's equal to, we also know C. So we set it up using C. I don't set up with all three pieces. I only pick 2 of the 3. Then I times by the sine of 35, so those cancel. We get times the sine of 35, so A equals that whole piece. And notice how similar it is to both ones. Okay, so that's what I do. I go the sine of 35 times 10 over the sine of 105 gives me my first answer of A is 5.94. So 5.94. Then I do the same thing for B, except instead of 35, I've got 40. So the sine of 40 times 10 over the sine of 105 gives us 6.65. So 6.65. Alright? Okay. So, same idea here. This time I've got 2 angles. So 30 and 45 give me 75. So this is 105. Okay. Found my angle. Now I've got, let's see, that's A. I've got the A set up, and I'm finding side B and side flip-flop those, didn't I? C and B. So we set it up the same way. Okay. If I'm looking at C, 25 and 35 give us 60. 180 minus 60 is 120 degrees. And then we're looking for side B and side C again. So we set it up in the same fashion. Okay. So let's do 15 first. So we've got, let's look for C first. C is equal over sine of 105 is equal to A, which is 40, over sine of A, which is sine of 30, times by that sine of 105. Those cancel. I'm left with C equals whatever this turns out to be. So I type it in. So 105, sine of 105 times 40 divided by the sine of 30. And that gives me for C 77.27, which it's the hypotenuse, it's the longer side looking, so makes sense. Guess that would be centimeters, right? Okay, then for B, we want to find B, and it's over the sine of 45, and it equals 40 over the sine of 30. So we're going to times by the sine of 45. Okay, because then that gets B by itself, and then whatever we have here is what our answer is going to be. So sine of 45 times 40 over sine of 30 gives me 56.57 when we round. And there we go, centimeters. There's 15. 16, same idea. Okay, we decided that that was 120. There's little c, little b. If I want to find b, it's b over the sine of 35 equals a, 21, over the sine of a, which is 25, times by the sine of 35 to each side. Those cancel. B equals sine of 35 times 21 over the sine of 25. So I get 28.5 for B. Centimeters. Do it for C. I want to find C over the sine of 120 equals A, 21, over the sine of 25. 25 times by sine of 120, so those cancel, leaving me c equals, times by the sine of 120, so same idea. Sine of 120 times 21 divided by the sine of 25, and we get 43.03 for our answer. And there we go, guys. So if we look at 17, what do we need in order to use the law of sine? Well, one angle and one side across from each other. Okay, that's critical. And then one other side or angle. One side slash angle. Because once we have one of those, we can easily find out the other one. But we have to have that connection. That was the connection. That was the connection back here. This was the connection. And I believe, yeah, similarly, that was the connection. So we've got to have that in order for it to work. Alright, so now we're going to take a look at the law of cosines, kind of see how we can use this one. We've got a couple problems for this, and then we'll be done. So here we go. Law of cosines is right down here, so let's see how we use it. So we've got this one angle, 115, and the two sides, 20 feet and 30 feet. So this is angle A. We want to find side A, right? That's one of the first things we want to do. Because with the law of cosines, you want to use it so that you can set it up to use the law of sines, because the law of sines is much easier. So if I can get a connection here, then I'm able to use the law of sines there. Okay, so we want to find that one. So we use the top one because we're dealing with A. So I go A squared equals, see, this would be B and C. So B squared would be 30 squared, plus C squared would be 20 squared, minus 2 times 30 times 20 times the cosine of angle A, which is 115. So I need to basically put that in the calculator. I'll simplify it kind of by hand. 30 squared plus 20 squared is 1,300, minus 2 times 30 times 20, 1,200, cosine of 115 equals A squared. So then I'm going to type this whole thing in there. So 1,300 minus 1,200 times the cosine of 115. And that gives me 1,807.141914. Then I've got to take the square root of that, right? So I'm going to try not to round as much as possible, so I keep this number in the calculator, and then I can square root it to give me my most accurate number. And we get 42.51 if I round. You want to wait out and hold off on rounding until the very end. So 42.51 right here. Okay? And I was just using that law of cosines. Now that I've got a connection, I can find angle B by using the law of sines. Sine of angle B over 30 would be equal to the sine of angle A, 115, over 42.51. So times both sides by 30. So I get the sine of angle B equals this whole thing. Okay, so that's the sine of 115 divided by 42.51 times that by 30. That gives me 0.63959618. So that was 6.3959618. Well, now I need to do the inverse sine of that. So once again, using my calculator, I'll just use that whole decimal and just hit the inverse sine of that number. And we end up with angle B being 39.76 degrees. So now that I've got two angles, I just take that and add 115 to it, subtract it from 180, and we get 25.24 degrees. Alright, So typically with the law of cosines, you end up using the law of sines as well. Alright, let's take a look at number 19 now. Okay. So once again, we're going to find that side A, because there's C, there's B, so we're using the top one. So A squared equals 45 squared plus 90 squared minus 2 times 45 times 90 times the sine of 30. Or not sine, cosine. Cosine of 30. Cosine of 30. Now, I'm just going to kind of shortcut this one and do all that work in my calculator. So I just type it in like that, 45 squared plus 90 squared minus 2 times 45 times 90 times the cosine of 30. That kicks out 3,110.194229. So I'll take the square root of all that, and we get A equals, and I'm doing all this work in my calculator, so I'm not having to round. We get 55.769111537. Okay, so basically we can probably round it at this point and go 55.77. Okay, now I can use the law of sines. So I've got the sine of 30 over 55.77, and the reason I'm putting the angles on top is because that's what I'm looking for. So let's go for angle B again. So sine of angle B over 45. So times both sides by 45. So I get the sine of 30 degrees divided by that 55.77. And multiply that by 45. That gives me 0.40344911107 equals sine of angle B. So now we do the inverse sine of this, right? And that's going to get us angle B. So the inverse sine of that answer gets us 23.79. So then 180 minus 30 minus 23.79, and we've got 126.21 degrees. And there we go. Okay, so same idea here. Alright, so now we've got all the sides. Okay, so that kind of changes things, right? So now instead of doing it the way we just did, we're going to be looking for angles. Okay, so we're going to be filling in all those pieces. So slightly different, but still going to work out the same way. Okay, so now hurry to answer 22 before, well, maybe we can move it down like this, clear some space to work. Okay, so I've got C, B, and A. Well, which angle do we want to find? Doesn't really matter, let's go for C. So it would be C squared equals A squared plus B squared minus 2AB cosine of angle C. So we know C squared is 30, so 30 squared equals A squared is 14 squared plus B squared is 20 squared minus 2 times 14 times 20 cosine of C. Now this one we can't really put into the calculator because there's two parts. This part's added together and being subtracted by this part, which is like the coefficient of cosine of C. So I can't subtract those. So I'm going to have to kind of work through it. So 30 is 900, 30 squared. 14 squared plus 20 squared is 596 minus 2 times 14 times 20, which is 560. Now, some of you will want to subtract that right now. You can't, okay, because it's multiplied by the cosine of C. So you actually subtract this piece. So we end up with, on the right side, negative 560 cosine of C. You've got to imagine it if it was like 2 minus 3x. I can't go 2 minus 3 and then give me my x. That's what we're doing here. So 900 minus 596 gives me 304. So 304 equals that negative 560. So divide by negative 560. So now we could find that decimal. However, for me, I would just do the inverse cosine of that whole fraction. That's going to give us angle C. So the inverse cosine of 304 divided by negative 560 gives us 122 point, if we round, 88. Okay, now once again, we used our law of cosines, but now we've got a connection between a side and an angle opposite each other. So now I want to use the law of sines, because there's my connection. And we're looking for another angle, so I go the sine of 122.88 over 30 equals the sine of, let's go for angle B, over 20. So I times both sides by 20. We get the sine of B equals whatever 20 times the sine of 122.88 divided by 30. We get 0.559872. So then I just hit the inverse sine of that answer, and that gives me 34.05 degrees. So angle B, 34.05. So then I go 180 minus 122.88 minus 34.05, and we get angle A is 23.07. Okay, and that's how we do it. So 21, same idea. Okay, this time let's go for angle A first. So it'd be the, no, let's do angle B. It'd be the B squared. So that's B, so I'd go B squared, 6 squared equals, that would be C and A squared, 16 squared, plus C squared, 18 squared, minus 2 times A times C times the cosine of angle B. So once again, 6 squared is 36, 16 squared plus 18 squared, because I can combine those two, is 580, minus 2 times 16 times 18, which is 576, cosine of B. Okay. Now, we're running out of time, so I'm going to do this work. I'm going to pause it, do this work, and then kind of talk you through it. So we subtract 580 from both sides right here. That gives us negative 544 divided by negative 576 gives us positive 544 over 576 equals cosine of B. Take the inverse sine, that tells me the angle, which when we do this in our calculator ends up being 19.19 degrees. Now we use the law of sines to figure out the rest. When we do use the sine, we get that angle equals 13.3, then take 180, subtract those to get angle C, which is 147.51. So in order to use the law of cosines, you need 3 pieces of information, right? An angle and 2 sides or 3 sides. And then you can find the other information and use the law of sines. Okay, now in these ones, finding the missing angles, well, we figured out last homework that these stood for something. So when we're dealing with the square root of 2, we should know that that's a 45-degree angle. Okay. When we're dealing with 1, that's a 45-degree angle. This was also a 45-degree angle. Okay. Now, we've also got the 30, 60, 90, the other special triangle, right? So, if we think about it, if this is 1, that would make the hypotenuse 2, and that would be the square root of 3. Okay. So, this would be the 30 and the 60. So 30 sine would be 1/2. So that would be 30 degrees. So the cosine of 60 degrees would also equal 1/2 because they're opposites. Then the square root of 3 over 2 would be the 60-degree angle. And then finally the tangent. If this is opposite over adjacent, it would end up being this one. So it would be 30 degrees. And then, so if 24 would be 60 degrees. And we know that because of those special right triangles and the patterns that they make. So there we go. Enjoy!